division, we're going to divide this polynomial, x cubed minus 4x squared plus 7x minus 1, by this polynomial, x minus 2. First, we're going to do long division, and then I'll show you what it would look like with synthetic division. Okay, so long division, you're going to set up just like you would set up a long division problem with regular numbers. Okay, so we're going to put the x minus 2 out here, a little bracket, and inside goes the numerator. So we've got x cubed minus 4x squared plus 7x minus 1. All right. And the thing that we don't have to worry about here that we usually would, you want to make sure that if you are missing a degree, so see I go from a degree 3, a cube, to a degree 2, to a degree 1, to a constant term, which is a degree 0. So if you're missing a degree, say I didn't have an x squared term, you'd want to make sure to put in a 0 where the variable of that degree would normally fall, and also make sure all your variables are in descending order, right? So starting with the highest degree, going to the lowest, and if you don't have a term of a certain degree, making sure to stick a 0 in there. The reason that is, it just makes it easier to keep everything straight. Long division of polynomials, it gets a bad rap, but it's not so difficult. It works on skills that you already have, which are polynomial addition and subtraction and polynomial multiplication. The only difference is because there are so many steps and we're trying to make sure everything is properly aligned the whole time, there's more room for error. So thankfully we have every degree of variable represented here, so we don't have to worry about that. So we have a nice setup. First steps first, we are going to see how many times this thing, x minus 2, goes into this thing, right? Just like, let me show you over here, like when we would have, let's see, over here, how many times does 3 go into 100? The first step would be to see how many times 3 goes into 1. Well, I can't put 3 into 1, so how many times does 3 go into 10? Well, that's 3. It's going to be the same kind of idea, but but we're going to ask ourselves, okay, how many times does this first term here, which in this case is x, go into this term here, okay? I'm going to ignore the 2 for a second. So what do I have to multiply x by in order to get x cubed? Oh my goodness. It's not agreeing with me. Okay, so the thing I have to multiply x by in order to get x cubed is x squared. So I'm going to stack that x squared over here, so all my x squareds are kind of in a line. So then, now that I figured that out, we're going to multiply. Just like over here, we would multiply 3 times 3 and put the result down here and subtract. We're going to do the same thing. So we're going to do x squared. And remember, when we're multiplying polynomials, I got to make sure to multiply each term. So first we do x squared times x. That gives us x cubed, which is what we wanted exactly. Then we've got x squared times negative 2 is going to be negative 2x squared, okay? And just like over in the regular number example we subtracted, we're going to subtract, okay? Over here, 10 minus 9 would be 1. Over here, when we're subtracting polynomials, it's just good to be cautious. So x cubed minus an x cubed, that's 0, which is what we wanted, right? And over here, we have negative 4x squared minus a negative 2x squared. And when I subtract a negative, that's the same thing as adding. So really, when we have negative 4x squared minus a negative 2x squared, that's the same as negative 4x squared plus 2x squared, which is going to be negative 2x squared, okay? Okay, so that's going to be a negative 2x squared, okay? So now, just like over here in this regular number example, we bring down the next term and repeat the process. We're going to bring down this term and repeat the process. So this is a plus 7x. And just to make this a little, just to make this a little easier, I'm going to get rid of that 0 because you don't really need to write the 0. Okay, so repeat the process. How many times does x go into negative 2x squared? The other way of asking that is to say, what do I have to multiply x by in order to get negative 2x squared? And that's just a negative 2x, okay? Because negative 2x times x will give us, will give us a negative 2x squared. So, again, I'm going to take this, bring it through here, just like once I bring down on this other side I've got going on, I'm going to do the same process, right? So, I've got I've got a negative 2x times x is going to give me negative 2x squared, which is exactly what I wanted. And then I've got negative 2x times a negative 2, which is going to give me a positive 4x. Okay. Then I'm going to subtract those. Just like over here, I would do 3 goes into 10, another 3 times. 3 times 3 is 9. And bring it down, right? Okay. So now we're going to subtract. I always put the parentheses around here just to make sure to carry over that negative. I think the biggest problem that a lot of people have when doing long division, like I said, is making sure everything's in order and you're not forgetting a negative sign or whatever it is. Okay, so we're doing negative 2x squared minus a negative 2x squared is the same as negative 2x squared plus 2x squared, which is just going to be 0. I'm not going to write the 0, but you can to help you keep track. So over here I've got 7x minus 4x gives me 3x. And then I'm just going to go ahead and bring down the negative 1. Okay, so now we're going to repeat the process again with this last term. The question is, how many times does this x go into 3x? Or the other way of saying that is, what do I have to multiply x by in order to get 3x? That's just going to be 3. So I put my 3 up here. Again, making sure to stack it on top of my constant term to make sure everything's straight. So, once again, I'm going to multiply this through. 3 times x will give me 3x. And 3 times a negative 2 is going to give me a negative 6. And I'm going to subtract these. 3x minus 3x is 0. Negative 1 minus a negative 6 is the same as negative 1 plus 6, which is just going to give me 5. Now, what do? Right? There's no other terms to bring down. Well, just like in this equation on this side, when I have a remainder, you might have been taught in school to put a remainder 1 like that. The other way we write that is to add on your remainder divided by the number you were dividing by, right? So, we're going to do the same process basically over here. Take your remainder, in this case it's 5, add on 5 divided by your divisor, which in this case is x minus 2, okay? So that is the entire process, and this is the solution. So if we divide x cubed minus 4x squared plus 7x minus 1 by x minus 2, we get this solution, which is x squared minus 2x plus 3 plus the quotient 5 over x minus 2. That's just our little remainder at the end. Okay? So now we are going to do this same process, the same division, but we're going to do the synthetic division. Now, I'm not a big fan of synthetic division, but to some people it's a little bit more clear. So we're going to go through it. The setup process is very different, and it does save time. There's fewer steps, so in some ways there's less room for error, but the setup is more important to get right. Because if you set up wrong the synthetic division, the whole thing is just a mess. So the way that we set up synthetic division bring back. Okay, here we go. So the way that we set up synthetic division is to take all the coefficients of the thing we're dividing. So here the coefficient of our x cubed term is 1. Here's -4 is the coefficient of our x squared term. 7 is the coefficient of our x term, and our constant term is -1. Again, if you did not have a term for a certain degree, say, we were missing the x squared term, you would have to put in a 0, okay? And so we do a little upside down box traditionally for synthetic division, and I'm just going to put in all of those coefficients in order from the coefficient with the that's attached to the variable with the highest degree all the way down to the constant term. So we've got 1, -4, 7, and -1. And we're going to put a number out here, and that number is the 0 of the thing we're dividing, okay? So the 0 is the thing you have to plug in order to make this thing 0. So the 0 of x minus 2, the thing I have to plug in to make this 0, is x is equal to 2, okay? So 2 goes out here. And this is a little bit tricky. I see students who put -2 outside of here. You're not putting this number down, right? This little -2. You're putting the 0, right? The thing that you have to combine with -2 to make 0, which in this case is +2. Okay, so synthetic division. We are going to, so we are going to, first things first, bring down this 1, okay? Then we are going to multiply the term outside, or the number outside of here, by 1, and put that number up here into this box. So 2 times 1 is just 2. Okay? Then we're going to add these two together and put the answer underneath. So -4 plus 2 is -2. Okay? And then just the same way, take 2, the number hanging outside, multiply it by -2, and put that answer up into the next available space inside your bracket. So 2 times -2 is -4. And then you're going to bring down the addition. So 7 plus a -4 is going to be 3. Okay? And same process. Take the number outside, multiply it by what you just got, so 2 times 3, and stick that number up into this little free space in the bracket. So 2 times 3 is 6, and then we're going to add. So -1 plus 6 is 5. Okay? It looks like a little hocus pocus, but it should also look very similar to what we just did, right? If you notice, these, what we just wrote down, are in order the coefficients of the answer we got when we did the long division. So this right here, this row, is the list of your coefficients in decreasing order. So we're going, first is your remainder. Okay, and then we're going up by degree. So this is your degree 0, this is your degree 1, and this is your degree 2. Okay, so, and I should write, these are the degree, or the coefficients. Coefficients of degree number, right? So 1 is the coefficient of degree 2, -2 is the coefficient of degree 1, and 3 is the coefficient of degree 0. So we've got our degree 2, which is x squared. The coefficient is 1. We've got our degree 1, which is x. The coefficient is -2. And we've got our degree 0, which is 3, and degree 0 is just a constant, so that's +3. And then 5 is our remainder. Remember, our remainder, we always write stacked on top of the thing we were dividing, which in this case, we're going to just bring back the whole thing here. So that's x minus 2. And so in this way, you can get the same exact answer, x squared minus 2x plus 3 plus a remainder, which is 5 over x minus 2. That's the same exact answer that we got the long division way. Both work. It's just up to whichever one you think is more clear.